And what I'm going to talk about today is the star core Zeus story. This is the idea that our solar system used to be a binary star system, and that the remains of the sun's partner star is still in orbit. And so I'll move into the evidence, but basically it seems there is a cold, dark, magnetic, massive object, probably 10% the mass of the sun, out there, generally in the direction of Sirius Orion, that's inbound and travels effectively in a quite eccentric cometary type orbit. Okay. I developed these ideas, well, initially stimulated by Velikovsky and his Worlds in Collision, and then I started looking at astromythology. And what I discovered was that you tend to get these very strange descriptions of thunderbirds in the sky, or dogs like, the dog star Sirius, or great eyes in the sky. But they're not scattered randomly over all the stars. They're clustered in this region. And so I built up a picture, and also based on the archaeoastronomy, that people had really observed something strange in the sky between Sirius, Orion, Pleiades, Taurus, up to the North Polar constellations. And so there really was something that had been observed a number of times, and that was associated with catastrophe. Now, without going into huge detail, because it will take too long, but read my book, Cataclysms and Renewals, the current position of the star core is basically between Sirius, which is here, which is 8.6 light years away, but the actual object is only about 250 AU, which is only about 6-7 times the distance of Neptune. So I'll show you the big difference in scales in a moment. As the star core comes back in this sort of transpolar orbit over the top of the sun, it's traveling up from Sirius, passes Betelgeuse, and carries on up through the Pleiades and on up over the North Polar constellations. It was observed first, we think, in about 2000 BC, maybe 1800 BC, and it's about 70 AU from the sun. And the reason I'm giving you those dates is because old Babylonian astronomy starts talking about strange things in the sky at that time. And basically, there are actual images, so people must have actually seen it. Okay, now the next question is it a one-off event? I mean, Velikovsky tends to think of like one-off catastrophe, or he actually had two, which is one at the end of the Middle Kingdom of Egypt, and then he talked about the end of the Bronze Age, or late Bronze Age catastrophe. But in fact, if you look at the climate history record, you see this very obvious periodicity and oscillation of the climate. We're looking here at the temperature in CO2 in the Antarctic ice, okay? And also you get the same sort of patterns in the Arctic ice. And all I'm showing here, there's a sort of big 120,000 year cycle, and then within each of those there is a 4,000 year cycle. The most recent sort of catastrophic events, we go backwards in time, here's 1628 BC, 5600 BC, 9600 BC, this is end of Younger Dryas, purportedly end of Atlantis, and then two further climate catastrophes going back into history, and of course it goes back and back and back. But the main point I'm making here is this climate variation is a natural process, and it's driven by an astronomical object. It's not something happening on the planet, it's something exterior to the planet. Okay, so just to visualize what I'm talking about, this is a very simple computer model of the solar system. Here's the star core, this is the orbit of Earth, this is the orbit of Venus, and I can actually make it run if it's going to behave itself. Okay, and so you see the star core come over the north pole of the sun and then cuts down almost 90 degrees to the ecliptic plane as it passes Earth. And I'm saying this transit point close to Earth and Venus is critical for some of the other ideas later. But just get the dates, so we're saying it's got a periodicity of about 4,000 years. So 1628 BC was its last flyby. That is dated by the explosion of the island of Santorini. But of course, there's lots of other events around the world, catastrophic events are happening around about that period. The previous cycle was what is called the Great Flood at 5,600 BC. That is dated by the sediment layers in the Black Sea. The Black Sea suddenly appeared in 5,600 BC. Actually, so did the English Channel appear at exactly the same time, and so did the Baltic Sea. So there's a major sea level change at that period. And obviously there's a lot of precipitation, a lot of other questions. 9,600 BC is end of the Ice Age, the Younger Dryas event, and then prior to that you've got the Bowling-Allerod event, and you've got this cycle of catastrophe about every 4,000 years. On this previous flyby, it was actually observed, and this is an astronomical picture from Assyria. So this is the star called Zeus. This is an image of the Pleiades. So it's quite often associated with Pleiades. But all cultures had a very similar sort of image. So Hittite Turkey, New Kingdom Egypt, Shang, China, Mycenaean Greece, Zoroastrian Iran, you've got these images actually on Easter Island, though there's now some talk. These Moa statues are very old, maybe they're 12,000 years old, but I mean, let's discuss it later. We've got Aztec imagery as well, which even though, of course, Aztecs are much later, they're remembering earlier events and mythologies, and also the Maya as well, and you've got the Tiwanaku culture showing similar types of images. And there wasn't just artistic images of the so-called sky god. You've got things like the Dendera zodiac. If you actually put actual star map locations onto that zodiac, you have Sirius, Betelgeuse, and this is well established. Orion is this thing here, and the bull here is actually Sirius. But the Eye of Horus, this is Horus symbol, sits in the same position. And this is the same position where it appears, well, actually that's the position where I think it's approximately now. But you've got a very similar type of picture on this petroglyph star map in a cave in Sardinia. It's enormous, actually. It's got scale there. It's like something like 10 meters. That's more than 10 meters. It's huge. Half a meter. That's half a meter there. So it's a huge thing. It's like a great big piece of carving. And yeah, and you've got Zeus, or some object has been observed traveling up towards Betelgeuse. That's an image of Betelgeuse. This is Orion spelled. Okay? And these are later images. This is Assyrian. So here you've got Zeus, you've got the Pleiades, this is the moon. That's probably Venus, I mean, as a brighter object. So various cultures placed it in this region of the heavens. Now, the basic idea I'm saying is that at the birth of prior to the birth of our solar system, we were a binary star system. We were the sun plus a star of 10 solar masses. Big stars have short lifespans, burn up their nuclear fuel very quickly, maybe 100 million years, and then they blow up. And if they're very big, they'll have a supernova explosion. And this is basically what it looks like. So this is the partner star of the sun. That's the sun. And when you have its binary orbit, you get the lighter object traveling much more around the center of mass, the barycenter of the binary system. So this is the sun making one of its orbital paths, and then, boom, big supernova explosion. So basically they are blown off in different directions, and in fact now, that is the sun, and that is the hot star core, the remains, but looking at it as if we're looking down the blast tunnel. Okay? Okay? So I've got that image to try and show you in reality. So, about 3 years ago, I gave a talk here and I showed this image. It's a fascinating thing. It looks like a cartoon explosion. It's a huge area though. It's 2,000 parsecs across. That's 6,000 light years. It's a map in the ecliptic plane. This red zone is ultra hot ionized, rarefied hydrogen, okay, and a few other elements. But basically, they're radiating X-rays. And the dark bits are dust. And what's happened is something blew up there, and that's where we're located. That's the sun. So a lot of dusty debris went that way, and most of the hot gases went that way, and I think the star core went that way as well. Now, okay, that was, when was the date on that? 2014. Now, in 2021, more data has come out showing that this structure here is sort of like a magnetized tube. And these are field lines where you've got ionized hydrogen, which are in magnetic structures, maintained in a magnetic structure. So that's the sun, and I'm saying Zeus, I mean, even on the scale, they're really on top of each other, you can't see it. But so I'm going to keep like zooming in. So we're 2,000 parsecs across, 1,000 parsecs across. Now we are 600 parsecs across, and you begin to see the, again, overall structure. You've got this tube of hot gas, which is rarefied, vacuum, very almost hard vacuum. And I'm saying Zeus, or the main part of the explosion, blasts off in that direction, and most of the convective layer of the star, or the former partner star, blew out in this direction, making like a reaction mass, like a rocket. Okay, that's 600 parsecs across, so we're talking there about 1,000 light years, okay? Now this is zooming in further, this is 6.7 parsecs across, so again you've got to multiply by 3 approximately, so that's about 18 light years across. And so Sun, Sirius, that distance is 8.6 light years, and I'm showing that Zeus is just like here, next door to Sun, but the direction is towards Sirius. Now, there's some very nice photos available now. So this is a high-resolution photo in both visible and infrared, showing the incredible amounts of dust around the Orion constellation. That is another galaxy. But in the region adjacent to Orion, I'm showing you on a star map here, so it's here, there's this is the entrance to the tunnel. It's a tube of vacuum, which is very, very hot. And I am locating the star core in this tunnel for another reason. And I want you to imagine what it looks like. It's like maybe a neutron star with a dusty torus. It's a magnetic object that's spinning. It's got radio jets. So it's got this funny spinning top look about it. Okay? But that's the general location. Betelgeuse is up there. Sirius is way down there. Now, there's more information on that. So here, there's different scientific publications. That's showing the dusty torus, dusty tube of the tunnel, and Zeus located in the middle. But that's when you're looking at dust maps. But when you look at hydrogen alpha, which tells you what's actually in these bubbles, the ones with red are radiating in the 21 centimeter range. And they are showing that these are recent supernova explosions, but the tunnel is something very, very old and has nothing in it. And then very recently, Gaia, which is the astrometry space telescope, which has been looking at the locations and positions of literally millions of stars, has been collecting information on the local dust extinction of starlight. That is, when starlight comes towards us, you can actually measure how much dust is in front of it, okay? And again, you get this very clear picture like something's there, and in fact, I locate, for different reasons, Zeus right in the middle of that black dot, right in the middle, there it is. And if I was to expand that out, galactic center will be over here somewhere, all right? So Orion is here, okay? Right, okay, so the star core, what is it? The star core is the remains of the core of the star, all the heavy metals as the thing burns, so it fuses nuclear fuel, making heavier and heavier elements. The point is, we observe, and it started off as a white dwarf, okay? But when we observe white dwarfs, there's a mystery about white dwarfs, because the ones you observe, you never see them below about 0.2 of a solar mass. So heavier white dwarfs shine brightly, but lower mass white dwarfs, you just don't see them. There's no light coming from them. And this is two different surveys. Here you've got, again, the same region. You see this is 0.5 of a solar mass. That's about 1 solar mass. There's just nothing there. And the same thing here. It's a different survey. There's nothing here. And the reason is that the big stars take a long time to cool down. That is the age of these white dwarfs. And so, you know, they're still quite hot at 8 billion years, so they're still radiating light. But something that's only 0.1 of a solar mass, because of the degenerate matter, it actually is larger, so it's a peculiar property of degenerate matter. Less of it, the bigger it gets. So the larger the surface area, the more it radiates heat, and it cools down quickly. And that's why you can't see it. But because it's magnetic, it does have a radio output. And basically it's a spinning star core remnant, which is magnetized. So you're getting radio frequency radiation. Now, it so happens there is quite a powerful radio source called 3C161, which was detected in 1950. It was one of the early, because it's quite bright, radio sources. No one knows what it is. It's a big mystery, because when it was first discovered, it was called a radio star, because it seemed to be a star. Then later, people said, no, all of these strange radio sources, they're all galaxies, they're far, far away, they're thousands and thousands of light years away. But the problem with 3C161 is that the radio frequency energy coming from it is both plane polarized and circularly polarized. If it was shining through the whole Milky Way, because the point I'm saying, this location is basically at the edge of the galactic plane, you would expect it to be completely depolarized. You wouldn't see this polarization because it's already been, the galactic magnetic field would have depolarized it. And again, these are the scientific publications that relate to this concept. And just so you know what we're talking about, I'm saying Zeus is there, that's Sirius, and that's Orion, okay? And I'm saying, keep in your mind, that's probably what it looks like, okay? Right, another story. There's evidence that 3C161 is close to the solar system. Okay, if you look at it in any journal, you'll see, normally they just say, they just don't know what it is. Some people will say, no, it's a distant galaxy. Some people will say, well, normally we don't know what it is. But when you look at the wind velocity of the hydrogen in the outer Milky Way, it's whizzing along at about 200 kilometers per second, because all this material is going round and round our galaxy, okay? When you look at the relative velocity of the solar system going through our local spiral arm, it's at 23 kilometers per second, right? That was measured by the IBEX spacecraft. However, when you look at the hydrogen wind in front of that source, you can only see very low velocities, 0 to 10 kilometers per second. That implies that this object is very close to us. There's no fast wind in front of it between us and that object, so it should be quite close. That's the first piece of evidence. Second piece of evidence is, over the years, over the last 40 years, 50 years, there have been various radio sky surveys, but when they locate 3C161, it keeps moving, right? So different surveys in a slightly different position, all right? And that most likely is due to parallax. Now, if it's a random set of dots, okay, that's just random bad data collection, okay? But if it forms a line, and if that line is parallel to the ecliptic plane, it's very likely to be parallax. That is, when the Earth goes around the Sun, you get a different viewing angle, and anything that is close to us changes its location with respect to the distant stars, okay? And I'm saying, based on that type of deviation, it's about 270 AU from us. Again, this little cartoon shows that effect. It's rather difficult to see, but you see that red dot moving against the background stars because the Earth is going around the Sun, and it's saying, so if you move something further away, the motion is less. But again, looking at the variation between March and September, because Zeus is in the sort of December midnight direction when we look up in the sky, you are seeing some parallax. And again, this is the same parallax data, just to get the scale of it. This is a star map, that's Orion, that's Sirius, and this big green box is that tiny oblong, sorry, that oblong is that oblong, okay? That's the ecliptic, and you can see that's the angle of the ecliptic, and you can see this thing is sloping up as well. And these dots all form a line. They're not all over the place. Okay, where's the radio signal coming from? Well, there are two places it can come from. It can come from Taurus, because there's this ionized matter whizzing around the star core in a very strong magnetic field, and so that's called synchrotron radiation, where you, in line of sight, this material is coming towards you and it radiates EM. The other place it can come from is the jet lobe, where you have the radio jets, and where it decelerates. Again, any decelerating charge or accelerating charge radiates radio frequency radiation. So these are just pictures. This these numbers are actually based really on interferometry of 3C161. So it's got a core which is about 0.3 arc seconds across, seems to have a torus of about 3 arc seconds, and a halo, that is the outer bits, about 10 arc seconds. Now, that's quite big, actually. It's quite a big angular size for, I mean, that's either a huge galaxy far, far away, or it's something quite local to us and much more reasonable in size. Okay? Right. Because of Mike's talk, I'll show the heliotale. So we've got, that's the sun, that's the solar wind, and it doesn't go out in all directions. It actually goes out predominantly in this one direction, all right, which is actually pointing towards 3C161. And that, you can maybe able to see that ring, looks like a target. That is the dusty blast tunnel. That's Sirius, all right. And again, I'm just showing that, so this is I've rotated a bit, that's the supernova blast dust coming off one direction and the star core going that way, and it's all pointing at the same thing. And because of the size and scales, the bubble around our sun where we're pumping out solar wind is constrained by the local magnetic field, and for some strange reason it's elongated, pointing in this direction. Okay, and I'll go into that in a bit more detail in a moment. So what I'm saying, 3C161 is close, it's inside the heliotale of our solar system. It's also in the middle of the blast tunnel 4.6 billion years ago. It's returning to the sun at the moment. So aphelion was about 350 AD, and it's on its way back. And it's, I mean, sun and star core are falling towards each other into the gravitational well. Okay, and I'm saying the period is 4,000 years. Right, just another nice little cartoon showing what the heliotale is all about. It's going to work. Right. Again, this is IBEX spacecraft data, but this is a simulation. But it's showing that, you know, the solar wind doesn't go out in all directions. It goes out in one direction, and it's constrained. This is a galactic magnetic field, and you get this you get faster and slower wind. But again, that IBEX data covers this region of the sky. Okay, so you're looking at Orion, Sirius, and more or less in the middle, Betelgeuse there, and I'm saying Zeus is there. Right, this, if someone's put on red-green glasses, you'll actually see the 3D. But basically what I'm showing here is our solar system flies through the galactic spiral arm at about 23 kilometers a second, and it's traveling towards this thing called the solar apex. The reason we know that is because you look at the motion of all the stars, and you can calculate from the motions, proper motions of stars, in which direction we're traveling. And so you see in this diagram, this is, imagine you're in a spacecraft, that's your front window and that's your back window. So things are sort of spreading out in the front window and they're coming together in the back window. And that's basically what's happening. But the mystery is that, okay, so we know the direction of travel, all right? But the solar apex, all right, is below Sirius, okay? But in fact, the heliotale is actually pointing up here where Zeus is, not there. So, you know, the imagination of the heliotale is that sun sort of blasts its way through the spiral arm of the galaxy, it's trailing behind this thing, and so it's simply sort of some inertia, you know, as if that's what's going, what you're leaving behind. But in fact, something's attracting the heliotale further to the north, and that is Zeus. And other bits of information, you may know this, that Sirius is one of the strange stars in the sky, which is blue shifted. That is, we are falling towards Sirius. Now, I'm not suggesting there's any weird gravity effect between us and Sirius, but I'm saying there's a dark mass between us and Sirius, and we're falling towards that. And that's why you've got that blue shift. And the most interesting thing, which still needs to be studied properly, is over the last 100 years, people have been measuring the radial velocity of Sirius, that is, how fast it's coming towards us, and it appears to be accelerating. All right? But I mean, I talked to astronomers at UCL about this and say, no, it's got to be data error, don't believe you, impossible. I said, look at the publications, it's accelerating. All right, I just want to show you this because it's an incredibly difficult problem to work out where things are in space because they're all moving. And if you look at the dates here, this is how the Orion constellation changes shape over quite a few short period of time, like 100,000 years. Okay, so that changes the Orion constellation, you know. I mean, okay, the main parts of stars are far enough away they don't move around too much, but you can see there's a lot of action going on. Right, this is very interesting. Okay, Caltech in 2016 said, I think we've got some massive body outside the solar system, called it Planet 9. And the reason they said that was they started measuring the orbits of all of these scattered objects on the outer regions of the solar system, outer regions of the Kuiper Belt. And so just get a picture of what you're looking at. It's a three-dimensional image. That's Zeus at 250 AU. That distance between the Sun and Neptune is 30 AU. So that's the scale. Kuiper Belt is all in this region, all this stuff's going on. Now, there are three pictures, and they're all very important. Right, this is the known positions of the Kuiper Belt objects. Now, what we expected with the Kuiper Belt, because it's way out on the edge of the solar system, there'll be no structure to it. It will just be, some random scatter of cloud of stuff. What you're getting is gaps, and you're getting resonances. All right, something is making these things happen. All right, and when you look at that gap, you find that all of the highly scattered objects, these are the Kuiper Belt objects that have got extremely eccentric orbits, extremely inclined orbits, are all being kicked out from more or less the same position, about 90 degrees longitude. When you look at the edge of the Kuiper Belt, again, you would expect it just to sort of fade out over hundreds of AU. It suddenly stops at 50 AU. Right? There's a big bang. And so basically, outside 50 AU, you've got this big wedge of Kuiper Belt objects. So what we're looking here is perihelion distance and eccentricity. All right? But beyond there, there's nothing. But when you calculate the likely orbit of Zeus, that is the position where Zeus is coming from ecliptic south and cutting the ecliptic plane and heading north before it goes over the top of the Sun. Okay? Right, this is also fascinating because this is just big astronomy. Right, first thing, that is Orion, and Sirius is there. Now, Caltech even went public and said, we think Planet 9 is here on that side of Orion for their reasons, their calculations of Kuiper Belt objects. My completely different reasons, based on astromethodology and archaeoastronomy, says Zeus is there. I mean, basically Planet 9 and Zeus are the same thing, it's just we're giving it different names. And that's fascinating. But even more fascinating is if you then look above Orion to the ecliptic, all the perihelia of all our planets are clustered there. All our planets have slightly elliptical orbits. They're not totally circular. And so the perihelia are all clustering. For some reason, something's making them cluster. Okay? And the effect of that, it can also be seen in a map like this, that the orbital poles is, when you have the elliptical orbit, it's the bit in the middle. It's not the actual point of where the center of the orbit, it's the center of the ellipse. And they all cluster on one side of the Sun on the same line as the orbital plane of what I'm predicting between Zeus and the Sun. So they're all over there. They're clustered. Something's clustering our orbital poles. In addition, the Sun is not perpendicular. The rotation axis of the Sun is not perpendicular to the plane of the ecliptic. It's tilted by 7.25 degrees. You can see it there. Now, it so happens that tilt, you're actually leaning, that's a perpendicular there, you're leaning towards the incoming Zeus. So it appears, again, hypothesis, as Zeus flew over the Sun, it sort of perturbed the axis of rotation of the Sun. Okay? At some point in the past, I'm not saying it now. This is also amazingly fascinating. Now, I must credit the person who did this video. It's called something like Morn 1415. Don't know who he is, but it's a beautiful thing. All of the planets lean in the same direction except for Venus. All right? So you can see it leaning that way. Forget about Venus, it's different. It spins backwards. All right? Look at the Earth. It's leaning in the same direction. Keep looking. Keeps coming. Mars, same thing. Jupiter, leaning in the same direction. Saturn, in the same direction. Something completely knocked over Uranus, but in the same direction. And then finally, here it comes. Neptune, again, same thing. All right? So what I'm saying, this is evidence there's something very big going through our solar system. I mean, again, if this is all to do with solar system formation, you just find some random scatter of orbital direction, I mean, rotation axis directions, but they're all lined up. Right. Okay. Can we see, is it in any survey, any visual survey? So I first looked at digital sky surveys of enhanced over a period. This is where they've taken optical images from big telescopes, processed the data, scanned the images. And there's, I mean, this is overly artist rendered, but this chocolate donut is basically something there, and that X is actually location 3C161. Okay, so can we see it on a more recent telescope? This is Pan-STARRS, which is a powerful telescope. I can't remember where Pan-STARRS is based in. It's Hawaii? I can't remember. Or is it Chile? I think it's Hawaii. Anyway, first thing, go back to what we're looking at. Sirius, Orion. The cross there is 3C161. There's this big round target. That is the tunnel, the blast tunnel. Okay? And now what I'm going to do is try and zoom in, if everything's going to work beautifully. Is it working? It should start to move, if we're lucky. Yes, it's moving. So we're zooming in on the cross. What's there? And at limited resolution, there's some funny shaped object. All right? Sort of a bit like a donut, maybe. Don't know. But that's absolutely limited resolution. But that's a visual image of where the radio signal is coming from. Okay. Now, in addition, there have been other space telescopes going up. WISE was an excellent telescope which could see the universe in infrared while it's orbiting above the Earth. So again, I'm going to show you the same thing. This is optical I'm showing you, right? That's Orion, Sirius, and that's the blast tunnel. You can see it. It's like the big circular target. Okay? Now, so we're going to switch to infrared now, if it works. Is it going to work nicely? Yes, right. So we're now looking at the infrared. And then we're going to zoom in, see what's there. And there's something there. Wow. Now, when I saw this, I thought, whoa, we've got a picture of Zeus. And that's actually on the front cover of that book. But, unfortunately, when I started to look at the likely distance of that cloud, it's much, much further away. Right? The reason I'm saying that is because these are different WISE images of the same object, all right? But the critical thing is these ones were taken in September and these ones were taken in March, and it doesn't move relative to the the actual background of fixed stars. What that means is whatever that thing is far, far away. It's very likely to be the original convective layer of our star, our partner star, got blasted far, far away 4.6 billion years ago. But it's still basically in the same part of the sky, so the other end of the tunnel. All right? Anyway, so we keep looking. Right, now I'm going to jump to Venus, because, again, this society was triggered by the interest in unusual properties of Venus. Okay, very recently, there's the Parker Solar Probe, did some flybys around Venus, and had an infrared camera, which actually could see in the red optical region plus infrared, and was detecting both light and heat wavelengths. And the most important thing, we know, and it was confirmed, the average temperature of the surface of Venus is 460 degrees Celsius, all right? And the atmosphere is cooler. I mean, basically, it's 300 degrees C at 20 kilometers. Now, the point is that's a problem, because if you believe that Venus is hot because the atmosphere is hot, it should be hotter than the surface, but it's actually colder than the surface, right? And in addition, with all the Velikovsky's talk about comets and comet tails, you can actually see the dust of Venus comet tail in this picture, right? And just to summarize, Venus has no day-nighttime variation in surface temperature. Surface temperature does vary between 438 and 482 degrees centigrade, but that's due to the height of the altitude of the land, all right? And actually what is higher is colder, and lower is hotter. So basically it's getting its heat from below the surface. And you probably know the atmosphere of Venus is 96% CO2, and the surface, top surface of the clouds is about 165 degrees C, all right? In contrast, Mercury, which is twice as close to the Sun, has a huge variation in day-night temperature, so it's going up to 427 degrees C, but it's still cooler than Venus, even though it's much closer to the Sun. And that's very hard to explain, the existing ideas. Again, I will focus on this point as well. The medieval astronomers, later astronomers, reported the ashen light of Venus. That is, Venus, when you're looking at it, when it's not reflecting sunlight, glows brown or red. And the point is that this strange light appears to be dimming, so it's as if the planet is cooling down. And we also know from modern experiments that the photons that land on the sun side are mostly getting reflected. It's got the highest albedo. It's very white clouds. It's got the highest albedo of the solar system, it's 76%. And in fact, it seems that more EM photons are being radiated away from the planet than is actually receiving from the sun. Okay? So this data basically disproves the CO2 IR insulation is the cause of Venus heating. Okay, so this is a flyby of Venus, and you can see these dark and light patches, self-explanatory, Parker Solar Space Probe. And you can see what is basically, you're seeing the surface of the planet through the clouds in the infrared, which means it's radiating infrared. It's not a blanket that's insulating it. All right? And so if Venus can radiate in the infrared, then the global warming idea isn't correct. So you can see that's the highland coming across, highland being cooler than lowland. This is showing you again. So that's a radar image, that's an infrared image. It's telling you there. Cooler, lowland's hotter. And that's just the original Soviet Venus surface image. Now this is a Venus Express picture. Venus has got a comet tail. People didn't like that, but it's got a comet tail. All right, so, and more recent data, this is last year, there's definite evidence now that basically Venus is molten. There are bits of colder rock that float around like on a magma ocean, actually, still in Venus. What I'm saying is Venus actually was captured by the sun very recently, probably 12,000 years ago. And Venus heating is like Io heating. So one of the moons of Jupiter is very, very hot and volcanic because it's got an elliptical orbit around a massive body, lots of tidal heating each time it orbits, it's getting squeezed and pulled and gets hotter and hotter. And I'm saying that's exactly what was going on to Venus when it was in an elliptical orbit around Zeus. I've mentioned all these things before. It's hot, it's cooling, there's so hot there's no planetary magnetism, and we can see the comet tail. And going back to a bit of archaeoastronomy and history, this is Hathor, the Egyptian goddess of Venus, and why does he have this particular headdress? Well, it looks maybe a bit like that, which is Venus and its comet tail. And separately, Inanna, in the 3rd millennium BC, was definitely being seen as a comet, and these cylinder seals are dating back to 2000 BC. And even in the original cuneiform, the actual cuneiform symbol for Inanna is a comet. And it must have been there a lot to be so influential. I'll only do this very quickly because I can speak a long time about this. But so the basic steps, I'm saying, how do you get from Venus going around Zeus to Venus in its circular orbit around the Sun today is like this. So we're saying originally Venus is orbiting in an elliptical orbit around Zeus. It then gets captured by the Sun. There was some particular point where maybe it was as far as its most distant aphelion point from Zeus, and it was very close to the Sun. Somehow it got captured. So basically, it's still traveling in the same plane as Zeus. It's not in our coplanar elliptic area. But this event, this big catastrophic event, is what was the trigger for the Younger Dryas climate disaster. Move forward 4,000 years. And you've got still Venus traveling in the same plane as Zeus. And there's another flyby which is recorded in astromythology, the association of Aquarius with the flood is due to the fact that actually Starkle and Venus were in the constellation, passing through the constellation of Aquarius when the flyby happened. Moving forward again, end of the Middle Kingdom, 1628 BC, again big dramatic event, lots of heating of our planet, so cataclysm of fire, and during that time Venus was actually in a gravity assist turn around Earth and was thrown out in this elliptical orbit. And I'm just giving you various directions, Sirius direction, Orion direction. And the reason I talk about this is because in Aztec mythology it says, if you see Venus at midnight, then doom will come. I'm effectively paraphrasing it. Well, you can't do that, because if Venus is close to the Sun, you should never see it at midnight. The only possible way you can see Venus at midnight is if it's on an elliptical orbit that actually crosses the Earth's orbit. So like Sun's behind you, Venus is, I'm talking about midnight, Sun's behind you, you're looking at Venus coming in at the Pleiades, it means you've got an elliptical orbit. And this is to explain a very strange thing that no one's explained, is the tidal phase locking of Venus to Earth. So basically, when Venus and Earth have a close approach, the face of Venus is always the same. It's phase locked to Earth. It means it must have come closer to Earth at some point to get that. And so what I'm saying, the way you get from this sort of elliptical, two elliptical orbits, is we had an interaction between Earth and Venus, and I'm saying this is the origin of the 1159 Late Bronze Age disaster, and that event, they didn't hit each other, they just spun around each other, circularized both orbits. So Earth orbit and Venus's orbit became more circular. Right, so let's move on to the end of the world. So Zeus is returning in 350 years' time. This is the orbital track from its aphelion point, which is near Sirius. And then these are all the dates and locations, how far away it is. And you see it's accelerating very quickly when it gets closer to the Sun. And I'm saying the bad days are going to be in March 2373, approximately. We'll do a bit of Hollywood for that. Right, Sirius, Orion, Zeus coming in above the Sun, above the North Pole, zoom in, it's coming in down, it's going to go wham, bang. Two suns in the sky, destruction of the planet, end of the cities, huge tidal waves, aircraft carriers disappear under the waves, mountains disappear under the waves. I borrowed all this stuff. I didn't make this. I just edited it. Okay. Final result, though, is that as you get this flyby, you see the planets all start to go in spirals. This is a physics model. It's a universe sandbox. I've done it. I actually flew this thing through our solar system. And so Zeus is on its way back towards Sirius at this point. And the point is, though, it doesn't destroy the solar system, because you carry on running a model, you find that the Sun regathers the planets. It's got powerful enough gravity to actually get everything back. And in fact, our planets actually travel like this normally, because, and I'll show you that as well, because we're flying through the, so look, this is the Sun traveling through the spiral arm of the galaxy, and it drags all the planets along with it. And if you were, again, if that was like you had a spaceship on the front of the Sun, you'd see this view of you're flying into the spiral arm of the galaxy. And the direction of travel, if that was your navigation map, is towards Vega. It's actually there. The solar apex is there. So generally, you're going that way. Okay, more recent evidence of this going on. We've found that magnetic bubble I mentioned to do with the original supernova explosion, you can actually visualize it now. So that's the solar apex. That's our direction of travel. And these are the field lines, the magnetized ionized gas. All right? And this was published actually it was in September. So it was only 6 months ago. Or more than 6 months, 9 months ago. Okay? Right, I'll do some little snapshots. In my book, I can't remember which one, I think, Cataclysms and Renewals, I talk about pole shifts. Okay, there's a lot of evidence that the rotational axis of the Earth has been changed on what is called the true location, geographic location of the rotation axis. However, it's very difficult to just look at geological data or climate data and say that's where the poles were. Very difficult. It's actually very easy to see where the poles were, because you can see where the equator was. Because rainforests mark the equator. And rainforests have moved around. All right? So basically, rainforests have wandered in South America from the coast of Venezuela right down into Chile, and in Europe, and well, I mean, there have been rainforests in Saudi Arabia, They've been moving locations of rainforests in India. And I'm saying you can add all this stuff up, you can work out where the paleo equators were, and then it's very easy to work out where the pole was. And I'm just saying there's evidence of that. I did that, right? But recently, in Nature Communications, other people have done similar things, but they're using the paleogeological history and showing that about 86 to 78 million years ago, in the geological record and looking at magnetized orientations of magnetized rocks, there's additional evidence of the North Pole has been located in different places. And they actually give a specific name. They call it True Polar Wander, TPW. Oscillation, TPW oscillation. So now people are beginning to accept the fact the pole moves around. Another piece of recent evidence is analysis of this ancient site from about 4,000 years ago called Tel El Hammam. It was completely obliterated. But what's mysterious is the destruction layer's got silver, gold, copper, nickel, iridium, platinum. It's basically lots and lots of supernova materials. So something very big and supernova associated was responsible for completely obliterating this building. And it's, you know, the bricks are melted, you know, there are very high energy impacts of microparticles into the pottery. As I say, there's all this alien heavy metal stuff. And it's not conclusive evidence, it's corroborating the fact something's very strange and bad happened in the mid-2nd millennium BC. Right, so are we going to ever see the thing? Well, we have a chance because, first, the Gaia spacecraft, which was launched in 2013, we're finally getting all the data. It takes a huge amount of data it generated, and it's finally becoming available. So I'm hoping in the full data release 3, we might have evidence, more evidence of Zeus. Okay? Separately, James Webb is now up there and functional. It's got its infrared cameras down at 7 degrees Kelvin, so it can see really cold objects, like 50 Kelvin object it can see. Problem about James Webb is it's very narrow focus, so, and everybody wants to point James Webb somewhere, you know, you can't control James Webb. They're not doing a sky survey. That's the point. What's good about Gaia, they were doing a whole sky survey, so you've got a chance of picking it up. But whereas Webb at the moment, they're just pointing at particular things. Okay? The other one that's interesting is what's called WFIRST, which will be launched in 2025, which is a wide field infrared telescope, which will do another big infrared survey. It would be a bit like WISE. And so there's a very good chance out of these new telescopes, we'll find something. Okay, so just conclude it on, well, I won't conclude it, there's one more slide. But okay, my books, I recommend reading them. Sorry, I only got one copy of each here. But this one's Astromythology, how I arrived at this hypothesis. Star Causes, I'm collecting, astronomy, geology, you know, climate history, lots of different bits of evidence that point in the same direction. And I have got a third book sort of in manuscript form, but I've been so busy. It's going to take other years probably before it appears. And then finally, I just want to show this, because it's very difficult to find Zeus, because it's a very, very busy part of the sky. This is where the galactic plane is. That's Orion. There's all this stuff. That's Orion. There's a lot of stuff. There's gas, dust, you know, lots of points of light, and you're looking for something that's black, right? So I'll just run this for a moment. It doesn't go a long time, it's about 20 seconds, but it just gives you an impression of what you're dealing with. You know, you're looking for a needle in a haystack. I'll keep pointing out, and we're in the same part of the sky. It's all around, this is literally very, very close to where Zeus is. It's Orion again, and it's back to looking at night sky. So, gentlemen, ladies, thank you very, very much. Any questions?